Let's look at question number 7. Ax plus b equal to cx plus d. Okay, now if you look at the coefficient of x, which is a and c, if this side is equal to this side, then a must, the coefficient of x for this side must equal to the coefficient of set x on the right hand side, and then similarly b, the constant, must equal to b. This must equal to b for it to become equal. Now let's look at this part here. F d f. This a, this b. Okay, fgx. Fgx is actually 2. X here is replaced by gx, which is ax plus b, and then plus b. For function f is 2x plus b. The x is replaced by gx, which is ax plus b, and this equal to x. Now, let's simplify this. 2ax plus 2b plus 3 equal to x. Okay. Now, bring this x over here. 2a x minus x plus 2b plus 3 equal to 0. Now, take out a common factor, which is x. So we've got 2a minus 1 and 2b plus 3. Okay. Now, on the right hand side is 0. That means to say, for this to be 0, 2a minus 1 must equal to 0. Similarly, there's no constant on this side. That means 2b plus 3 must be equal to 0. So from the 2a minus 1, so bring the 1 over here, the 1 over 2. Bring the 3 over become minus 3, and bring the 2 become the denominator. So b is actually equal to minus 3 over 2. Okay. Now, as for b, I would like you to try c. Okay. Let's proceed with a. Question 8. Let's try. fgx is actually 1 minus the x of the f function is replaced by gx. Gx is actually x squared. Now, so this is a composite function of fgx with this. We have done this. Okay. Now, what about this? The range and the domain. Let's look at it. Since it's a square root, inside here cannot be negative. Okay? It means the x value cannot be more than 1. I mean the x square value here. If the x square value is more than 1, then 1 minus value more than 1, it becomes negative. If it becomes negative, then the square root of negative, which is undefined. Okay? That means to say, if I take this out, 1 minus x squared, can it be 0? Yes, it can. Okay, if it becomes 0, then the square root of 0, there is still some value. Yeah, it becomes 0, it's okay. So, what I have to do is, first, it must become 0, or it must be more than 0. If this value become more than 0, then you can square root it. So 1 minus x squared must be bigger or equal than 0. 1. Okay, now I believe you still remember what I teach you in looking at the inequality. Now, how to sketch this? First of all, let 1 minus x squared equal to y. You can sketch this. When y equal to 0, when y equal to 0, 1 equal to x squared. Therefore, x becomes plus minus 1. Okay? Remember this minus x squared, so it's maximum curve. Okay? And then when put y equal to 0, you follow the x-intercept. So it's here minus 1. Here is 1. So it actually okay. Now, for the y value to be more than 0, so basically your x value must be from minus 1 to 1 for the y value to be more than 0. Okay. We have replaced 1 minus x squared to be equal to y. So this y must be more than 0. Y 1 minus x squared equal to y. Y must be more than 0, we're saying. So more than 0 is above the curve. So for this to happen, x value must be from minus 1 all the way to 1. Okay? If you have the x value that is more than 1, okay? For example, x value that's more than 1. You intersect with the curve, and then it gives you a negative y value. Okay, but the condition here is 1 minus x squared will replace y, y must be more than 0. So x cannot be more than 1. Okay, similarly x cannot be less than minus 1. It has to be in between minus 1 to 1. Therefore, the answer is x must be more than equal minus 1, 1. Okay, T is the domain. Then the range will be, this is the point 1, okay, the y-intercept, 1 here. So this one is actually, the y value must be less than or equal to 1. Okay? Because the maximum can go is 1. If you use the completing the square, you know that the maximum